Right, so welcome to another segment of my physics videos as I now try to focus on how to calculate the refractive index using real and apparent depth. So now you might have actually stood near a swimming pool, and the swimming pool happens to be closer than it normally is. It is because of a phenomenon called refraction that it actually takes place at the boundary of air and water. So you can calculate what we call as being the refractive index by using, so the refractive index can be calculated by using what we call the real depth divided by what we call as being the apparent depth. So now how do you know which one is the real depth and which one is the apparent depth in order for you to calculate the refractive index? Well, let me give you an example. If you have got water, in some sort of a beaker that you have, let's assume that there's a coin at the bottom there. You put a coin, so there's water there, but you put a coin at the bottom. So this is what we are calling as being the object. So the distance from the surface of the water to where the object is, in this case the coin, the distance starting from, so you start measuring from the top surface there. This is what we call as being the real depth. All right, let's say that the real depth there is actually 4 centimeters. Then as you look at it, as you look at the coin, if this is the eye position that you're having, the coin is going to appear to be closer. Let's say that the coin appears to be somewhere here. Of course, if I try to look at it in this case, if I was to draw, if I was actually to draw the rays that are actually coming out from there, you'll be able to see something like this that is actually coming out. So the coin will appear to be there. This point where it is, that is where we call the image. So this is where the image is going to be formed. The distance starting, we start always from the top. So the distance from the top to to where the image is formed, where your eyes perceive the coin to be, that is what we call as being the apparent, so that is called as being the apparent depth. So let's say that the apparent depth is 3 centimeters. You can actually calculate the refractive index, because the refractive index is equal to the real depth divided by the apparent depth. So in this case, the real depth from here to there is 4 centimeters divided by the apparent depth from here to where the image is, so that is 3 centimeters. You can see that your refractive index will be 1.333, so we can just leave it to 2 decimal places. In fact, this is actually the refractive index of that is the refractive index of water. So that's the way you can actually get to calculate that. Well, let's look at a question that came in an exam and see what they are going to be asking you. For example, one of the questions that came in the exam, so they actually drew something that looked like this. So there was an object at the bottom there, which was a coin at the bottom, and the water level was there. So the image was actually being seen when being viewed from the top. Then they gave us the distance from here to there. That distance was actually 15 centimeters. Then they also gave the distance to where, in this case, the image appears to be formed. So that distance there was actually 11.28 centimeters, and the liquid there was simply water. So the question was saying, there were so many questions, state Snell's law. So remember Snell's law, if we talk about Snell's law, it is actually the law that says that the ratio of the sine of the angle of incident to the sine of the angle of refraction is a constant, and that constant is what we call the refractive index. So that is basically Snell's law. So that is what we call as being Snell's law. The ratio of the sine of the angle of incident to the sine of the angle of refraction is always a constant. All right, so that's what it was actually talking about there. Right, so could have just thrown it the way it was, could have actually just thrown it the way it was here. But anyway, basically it looked something like this. Then it says, what happens to the ray of light at the surface of water? So at the surface of water, there's always the bending of light, and that is called as being refraction. So at the surface there, refraction is going to take place because there will be the bending that will take place there. Then the last one was saying calculate the refractive index. So if you wanted to calculate the refractive index, remember what I said, it's the rule depth divided by the apparent depth. So the rule depth was actually 15 centimeters divided by the apparent depth from here to where the image is, that was 11.28 centimeters. So if you were to actually punch it onto your calculator, 15 divided by 11.28, we are going to find that it is going to give you 1.33. So that's what they wanted you to do in that exam. So it's very simple, it's not complicated. Now you need to be careful with some questions. Let me show you the other question that came in the exam and what it was actually asking you to calculate. It was simply asking us to calculate the refractive index, but one, needed to be very careful. For example, if I look at what the question was actually asking about, let's just try to look at again this question. Pay attention and try to see how you can go about it. So there was water again, and there was an object at the bottom. Then the image was actually seen there. So that was the image and that was the object at the bottom. Then the distance from here up to the bottom, they gave us to say that is 3.3 centimeters. Then they told us from here up to there, that is representing 14 centimeters there. Right, then the person was viewing actually from there, from the top. So you can see in this case what was what was happening there. So it was actually being viewed from this angle. So the rays are supposed to go in that direction. So we can tell you to complete up that. That's the way it's supposed to be. Now if you notice, now the question was saying that calculate the refractive the refractive index. So if I was to calculate the refractive index, yes, the refractive index is equal to the rule depth over the apparent depth. So the rule depth, yes, from here to where the object is was actually 14 centimeters. But what about the apparent depth? Well, people would have rushed to say 3.3, but that is actually wrong. The apparent depth, you need to start measuring from the surface of the water to where, in this case, the image is. That is the apparent depth. So for you to get the apparent depth, you needed to get 14 minus this distance, 33.3. So it would have been 14 over, and if you subtract, in this case, 14 minus 33.3, it is actually going to give you 10.7. Remember, all these are in centimeters. So 14 divided by 10.7, that is going to give you 1.31 to 2 decimal places. And this was the correct answer that you needed to find in that multiple choice. So please take note as you deal with the real and apparent depth. Now, one last thing that I want to actually show you is that, the refractive index, we can actually plot a graph of real and apparent depth. So what is going to be happening is that you can actually plot what we are calling as being, so on the y-axis, I'm going to put up the real depth, and that real depth can be in centimeters. And this side on the x-axis, I can have the apparent depth again in centimeters. So when you plot a graph of real against apparent, you are going to have a straight line of best fit. So if you were to calculate the gradient of this line, this line, that is the change in the values of x representing the apparent depth and the change in the values of y, they are representing the real depth. You are going to find that if you were to find the gradient, the change in y over the change in x, in this case y is representing the real depth over x is representing the apparent depth. You can see that the gradient of this line will actually be equal to what we call as being the refractive index. So that is what the gradient actually represents. It actually represents the refractive what? The refractive index. So you shouldn't forget this, because they can tell you to actually plot, and whenever you are plotting any graph, make sure that you have a title. The axes are labeled. So what would be the title of this graph? It is actually going to be, graph of, I'll write RD, real depth, versus or against apparent depth. So that would have been the title for this graph. Thank you so much. Watch out for some other videos, then you can actually get to learn a whole lot of concept together with questions, past examination questions that have actually been been solved. If you need lessons in Livingstone or online lessons, you can please contact us on this number. You can either WhatsApp me on this number, that is Mr. Nyendwa. Yeah, so you can actually WhatsApp me. Then of course we can actually get to interact, even physical or online lessons. Thank you so much for watching. Please enjoy the videos.